Mm-hmm. All right, so I'll get everybody caught up to speed while you're still getting there. We're talking about 8.2. We're talking about exponents, properties that involve quotients. Now, what's quotient? What does that word mean? Quotient. Mean fraction. Yes, very good. So the essential question here today is, how do we use properties of exponents involving quotients? And here's kind of, I'm gonna tell you the rule, but I want to show you where the rule comes from because I think it's kind of interesting. All right, so take a look at my little eights here. What do we call this? The top side of a fraction. What do we call that? The numerator. Good. Okay. There's a numerator. What do we call the bottom side of a fraction? The denominator. Yes, you guys all know this. This is nothing new. Okay. The denominator. What can I do with some of the eights in the numerator and some of the eights in the denominator? Yeah. What do you think? Yeah, I can. Right. I can cancel this one with this one. Why am I allowed to do that? Because they what? They're lined up. But what's the quotient of 8 divided by 8? How much is that? 1. That's 1. And what's 1 times any number you can think of? The same number, right? So I'm good to go. Like 1 times 5 is 5. 1 times 314 is 314. So whenever you multiply by 1, you don't change the values, right? Well, can I do this any more times? Yeah, I can do this one and this one, right? And I can do this one and this one. And then I can do this one and this one. And because I am multiplying all of those, I'm good to go, correct? So what am I left over with for my answer here? Yeah, so this is just an answer of 8 to the power of the exponent of what? Yeah, because there are 4 of these left over, 8 to the 4th, right? 8 to the 4th. But let's go back and let's see here. So I know that the answer, the end result is 8 to the 4th. Is everybody okay with that part? Everyone agrees that that's the answer? Okay. Let's go back here. How many 8s total were in the numerator before? 8 to the power of, there were 8 total, right? If I count them up, 1, 2, 3, 4, 5, 6, 7, 8, right? Okay, good. And then on the denominator, how many 8s were there? Yeah, there are 8 to the 4th. Okay, good. So the question then becomes, how do I get an answer of 8 to the 4th out of this right here? Who sees it? I got 1, 2, 3, 4, 5, 6, 7, 8, 9 hands up. All right, Damien, what do you think? What do we do? Subtract what? He says subtract the exponent. Is he correct? Yes, he's absolutely correct. So this would just be nothing more than 8 to the 8 minus 4, which gives us a grand total of 8 to the 4th, which is a way easier way to deal with that. How many of you guys kind of already picked up on that beforehand? Okay, awesome. I thought so. So can we talk about the general rule then for this? Okay, same box here. Let's talk about the general rule. All right, here's the rule. The rule says this. It's the quotient of rule. So let's write that down. Quotient of powers rule. It says if you have a raised to the exponent of m divided by a raised to the exponent of n, are the bases the same? Yes. Are the bases the same? Yes, they are, right? The bases are a, and they are the same. So if the bases are the same and I am dividing, then I am allowed to say this is the rule a to the power of what? M take away n. You guys got it. All right, let's practice here with these 4 examples. Okay, I have 6 to the 12th divided by 6 to the 5th. Do I have the same bases on the numerator and the denominator of my quotient? Yes, I do. So that's going to be 6 to what power? 12 take away 5, which gives me 6 to the what power? And we're going to leave it like that. That's a pretty big number. All right, let's try B. I have negative 2 to the 7th divided by negative 2 to the 4th. So I'm going to apply the quotient rule. Negative 2 to what power? 7 take away how much? Take away 4, so what would that be? Negative 2 to the 3rd power. We'll leave it like that. Okay. Ooh, part C. Now, let's just take a look at the numerator first. Look at the numerator first. What do we have to do? We have to do it. We got to clean that up. We got to add it. Good. I'm glad you saw that. So that's going to be 4 to the 2 plus 8 was how much? 10. Good. And then divided by 4 to the 4th, correct? So therefore, we have 4 to what power? To the 6th, because 10 minus 4 is 4 to the 6th. Awesome, awesome, awesome. And then lastly, part D, we have 1 over y to the 9th times y to the 12th. Well, that's the same thing as 1 over y to the 9th times y to the 12th over 1. And what do you do when you multiply two fractions together? When you multiply two fractions together, what do? You go straight across. So that's just y to the 12th divided by y to the 9th. And since they have the same base, y to the what power? Yeah, 12 minus 9 gives me an answer of y to the 3rd. I did this one yesterday. I'm going to reinforce it here. The power of a quotient rule. So the power of a quotient rule says if you have a quotient, so let's say you have a divided by b, okay? Now are those the same base? No, they're not. They're different, right? So these are different bases. So a over b. And if I raise this to a power of, let's say, m, what do I have to do to each base? Sasha, what do you think, buddy?
You have to distribute the exponent to each one of the different bases.
Yes, he says make sure that each base has that power of that exponent delivered properly to it. That is our rule of power of a quotient. All right, so a over b to the all to the m, you make sure every single base inside there gets delivered, okay? And we'll do some examples. We'll do 2 examples. All right, let's try this one together. Let's try, how about, you guys going too fast? So let's try a here. Let's do r over s all to the 5th power. And then b, let's do negative 4 over w all to the 3rd power. Okay. So example A, r over s to the 5th power. What do I need to do to make sure? Yeah, so it's going to be r to the what power? R to the 5th over what? S to the 5th. Yes, very good. That's pretty easy, right? All right, next one. Here we go. Negative 4 over w to the 3rd. What do I do? Distribute. Yeah, so I'm going to have negative 4 to the 3rd all over w to the 3rd. Very good. What do you guys think? Easy, medium, or hard? All right, here we go. All right, we got 2y to the 7th over y to the 5th, all raised to the 3rd power. What do we need to do first here? Yeah, we're gonna work from the outside in. Okay, we're gonna work that distribute exponent there. So that means I'm gonna have 2 to the 3rd power, because I need to take this base and raise it to the 3rd power. I'm gonna have y to the, if I take raise a power to a power, what do we do? Multiply. What's 7 times 3? 20, 21. Good. And then I'm gonna raise a power to a power over here. This one, what do? Yeah, all divided by y to the how much? 15. Okay, so far so good. Step 1. You guys good with that? Okay, good. Now, how much is 2 to the 3rd? 8. Very good. That's just 8. Now I have a base of y and on the numerator and a base of y on the denominator. So therefore, I'm going to take y to the 21 plus 15 minus 15. So I get a grand answer of 8. Y to the how much? 8y to the 6.